Hello guys, you're welcome back to my channel Fun with Physics. In this lesson we are going to look at how circuit components affect the current flowing in a circuit. Now, circuit components we know provide certain degree of electric resistance. Electric resistance is actually the resistance offered by components like, let's say, a bulb, a buzzer, and so on to the flow of current. Okay, now circuit components actually don't allow current to flow so smoothly because they are present. Okay, now how do you think current will be affected if you have, let's say, more than one component in the circuit? For instance, if you have like 2 to 3 bulbs in a circuit, how will the current produced, current flowing in the circuit, how will it be affected? Will it be bigger or smaller? Guys, you can jot down what you think on a piece of paper and then compare your idea with your new line of thought after the lesson, okay? Or you can comment on the comment section below. Okay, what do you think? Okay, now let's start with this. How components affect the current in series circuit, and then we are going to look at how components affect current in a parallel circuit. Now, for series circuits, current in a circuit can be changed when you change the number of components. Let's say you decide to increase the number of bulbs from 2 bulbs to 3 bulbs and so on. Or you decide to increase the number of cells. These are some of the things that actually affects the current. So when you change the number of cells, let's say from 1 cell to 2 cells, which is battery, and so on, the current of course will be affected. But what will happen when the number of bulbs is increased from, let's say, 1 to 2 bulbs and from 2 to 3 bulbs in a series circuit? What do you think will happen to the current flowing? Is it going to get bigger or is it going to get smaller? Now, if you have a 0.9 amp current flowing being supplied by itself, for instance, to a single lamp in a circuit, now you decide to double the lamp, the current actually will be halved. Okay, instead of 0.9 amps supplied by a cell, the cell will rather supply half of it, which is about 0.45 amps, since you have 2 similar components. In other words, what I'm actually saying is this: a single component provides certain resistance to the flow of charge, but when you double the component, it will provide twice as much resistance to the flow of current. It will provide so much resistance to current flowing in a circuit. This is synonymous to a case where you have 2 boys in a rope model holding the rope, gripping the rope, and then one trying to pull the rope. Okay, so when you have 2 people gripping something, the resistance will be twice as much as when you have a single person. Okay, now in this case, the brightness of the lamp will eventually drop since less amount of energy is being supplied. Remember, the charge is the one that supplies the energy. So when you have, the more you add more components in the circuit, let's say the components are lamps, the brightness of the lamp will reduce. That is to say that the resistance has increased. The resistance to the flow of charge has increased. Is that clear? Now, with a buzzer in the circuit, the electric resistance is even higher and less current is going to flow. Okay, because a buzzer provides more resistance compared to a lamp. Okay, now voltage can also affect current. When you have a single cell, let's say, supplies 50 milliamps to a lamp. of energy to a lamp. Simple stories, 50 milliamps of charge flowing. Two 1.5 volts, which is about 3 volts cell or battery, we supply twice as much. Okay, so when you have 4 of them, it will supply times 4 of it. Okay, times 4 of the 50 milliamps. Now this goes a long way to say that the more you keep adding, increasing the voltage, the more the charge, okay, produced, the more you produce the charge. Okay, they are directly proportional. When you increase the voltage, you are increasing the charge flow in the system, in the circuit. A single 1.5 volt battery supplies 50 milliamps. Then for two 1.5 volt, let's say 3 volts, it will supply 100 milliamps and so on. Okay, we explained that earlier. How components affect current in a parallel circuit. Now we've discussed this for series arrangement. We can come up with a conclusion here that in series arrangement, when the electric resistance is increased because of the components being increased, the current flowing will eventually drop, will decrease. So resistance here is inversely proportional to the current. When you increase the component or the resistance to the flow, you are going to drop the current, or you are going to decrease the current. Okay, and also when you increase the voltage, you will increase the current. So in this case, it's they are directly proportional. So voltage and current are directly proportional, but resistance and current are inversely proportional. Are we good? All right, we'll get to know more as I proceed. Now, for a parallel arrangement, let's look at what is going to happen. How components affect current in the parallel circuit. With a single lamp, the current flow in a circuit is 0.4 amps, but with 2 lamps connected in parallel, current flowing is increased to 0.8 amps. Why is that possible? How is that possible? How is it possible for the current to be increased from 0.4 for a single lamp to 0.8 amps for 2 lamps? Now, for 2 lamps connected in parallel is similar to connecting each lamp with a separate cable, a separate loop of wire to the cell directly. Okay, similar to connecting this lamp to the cell, this one to the cell. So if you connect both to the cell, each will be supplied with 0.4 amps. Okay, and the net charge coming out or giving to both of them will be 0.8. Okay, that's similar to this. So when you have 2 lamps in parallel, the resistance will be lower. Okay, when you have 2 lamps connected in parallel like this, more current will be supplied because the resistance of these components will be less. That's just a clear explanation. Okay, now the brightness of the lamp remains the same when more lamps are added. So if you keep adding 2, 3, 4 lamps, the brightness will remain the same. Are we good? Because each of the lamp will still get the same amount of current, 0.4 amps, and the same amount of energy. Are we good? Okay, this means that resistance of a lamp in parallel circuit is lower with more components. So with more components here, the resistance gets to be lower. But in a series arrangement, it's different. It's a different case. Are we good? All right. Now, what happens when you add more cells? When you add more cells, of course, the current will be increased. So we can come to a summary here that when you add more, when the resistance is lower, like what we have in this case, when you connect these items in parallel, the current gets to be higher. So it's inversely proportional. So resistance is always inversely proportional to current. That means when resistance is lower, the current gets to be bigger. Okay? And when the voltage is bigger, the current also gets to be bigger, direct proportion. So with big voltage, you get big current. But with small resistance, you get big current. Okay, so we can come up with that conclusion and come up with a useful formula that is very important for us to use. So current in a circuit depends on the resistance, that is the number of components, and the voltage, that's the number of cells in the circuit. Current will increase with increased voltage, correct? But it's going to reduce when the resistance is increased. Okay, like what you have in the series arrangement. Okay, current will increase when the resistance is reduced, like what you have in the parallel arrangement. So it's vice versa, right? It's inversely proportional. So with that, we can come up with this formula. Current increases with voltage, but current decreases when the resistance is high. Increases when voltage is high, but decreases when resistance is high. Okay, so with that, we can represent it in this formula this way. I equals to V over R. The unit of voltage is volts and resistance is ohm. So if you have I equals to V over R, you can represent it in a triangle formula in case you want to calculate for V. Remember, V is the numerator here, so it stays at the top. I, R multiply each other when you make V the subject, so they stay below. So you want to calculate V, you have I, R. You want to calculate I, you have V over R. And most importantly, when you want to calculate R, which is the resistance in this circuit, you say voltage over current. So in summary, the resistance in the circuit can be calculated from this formula. R equals to V over I. And the unit is ohms. Are we good? All right, perfect. Now in summary, for our series arrangement, when we added more components, the current dropped because there is more resistance. But for parallel circuits, when we added more components, the current actually increased because there's less resistance. When you keep adding more components in parallel, you get to have a less resistance. Okay, that is how it works. But in both cases, when you keep adding more cells, the current increase. Are we good? All right, perfect. Guys, if you have any problem, any question, please, or anything you don't understand, please leave your comment in the comment section below. All right, leave your comment in the comment section. Are we good? Right, don't forget to like this video and to subscribe for more videos like this. Thank you.